Welcome back. This is the day the Lord's made. Let us rejoice and be glad in it. In this video, I'm going to talk about a series of parallel circuits and do a little bit of math with them to do a little calculations of voltage, resistance, and current to give you a little practice doing so. All right, so here we have a circuit here. We have an 18-volt battery. We got two resistors, a 4 ohm and a 2 ohm resistor. So these two resistors are in series because every electron that leaves has to go through both of them. If you go along the top, you gotta go through the 4, come back through the bottom, you gotta go through the 2. So when something's in series, you add them both together. So the total resistance is 4 plus 2. We have 6 ohms resistance total we gotta go through. To find the current that actually decides to go through this, it's gonna be equal to the voltage divided by the resistance. So we have an 18-volt battery. We have a total resistance of 6 ohms. 18 divided by 6, we have a total of 3 amps that are taken off. Again, the current depends upon how much motivation the electrons have and how much resistance there is. So if the resistance goes up, we get less current. Now, the voltage drop, again, as the electrons go along, they're going to lose some motivation. And they start off with 18 volts of motivation. They're going to lose some going across here and lose some going across here. To find the voltage drop, we're going to take the 18 volts, which is our total motivation, and multiply by how much resistance this one provides as a whole. So we have a 4 ohm resistor there. It represents 4 of the total of 6 ohms of resistance total. So again, this resistor we're talking about, the 4 ohm resistor, is 4/6 of the total resistance. So we're going to use a total of 12 volts of motivation going across there. The 2-volt one, we're going to use less of our motivation because it is not quite as difficult as the other one. This is just saying that you will use more of your motivation across more difficult things. So for this one here, 18 times a third, this will use 6 volts of motivation. So again, because this 4 ohm resistor is bigger, it's going to use more motivation to get through. It's going to take more of your energy for you to get through it. So again, electrons are the perfect students. They spend all their energy. They don't do everything half, they do it all, and they spend it all. By the time they get down to the day, they are spent. So 18 volts. Going across this, we lose 12 volts. Now we're down to 6 volts motivation. Going across this last one, lose the last bit. We have no more motivation. We're done. Now to find the power actually used, let's change those numbers. How much power is going to be used by those two resistors then? Power equals voltage times current. So both of them are going to get 3 amps of current. The voltage, we only get to use the actual voltage they're using. So for the 4 ohm one, it gets 12 volts, not 18 volts, but 12 volts. All right, because it only gets to use whatever motivation it actually has. So that's going to be 36 watts right there. The other one is going to be, we get 6 volts of motivation for that one, but we get 3 amps still. 6 times 3, that's going to be 18 watts. Total power then to be used, add those both together, 36 plus 18, that's going to be 54 watts total coming across here. We could have solved that way as well, total power, by just saying, well, we have 18 volts of total motivation. We have 3 amps total going through. That's going to be 54 watts. So we could, I just broke it down into the 4 ohm and the 2 ohm because they're not using, we're using 54 watts total, some here, some there. All right, now let's look at a parallel circuit one. In a parallel one, the electrons get a choice. They can go top or the bottom. So it's helpful when you're doing some calculations to actually think about the parallel being in series. And so for the scope of this class, that's what we're going to do, okay? So if we have a 6 ohm and a 3 ohm resistor, we got to figure out what the total resistance actually is. What does this look like? So since I'm giving the people an option, they're going to feel like they're going to be less resistive towards it, all right? To find the total resistance in parallel, we take 1 divided by the resistor plus 1 divided by the other resistor equals 1 over X being R being the total resistance. So solve this 1/3 plus 1/6, and then solve for the total resistance on the bottom, X is 2. All right, so you can plug that in your calculator. So if you keep plugging your calculator, what you get is 1 divided by 3 is 0.33 plus 1/6, that's be 0.17 equals 1 over X. 0.5, that's 0.33 plus 0.17 equals 1 divided by X. To solve for X, we take 1 divided by 0.5, looks like 2 ohms. So we can think of this here, this parallel part actually looks like this here. We can think of this being just a series circuit because in this class, we're not going to split the current up and actually do calculations there. So we're going to pretend this is just this looks like a 2 ohm resistor. So the total current, we have 12 volts of motivation. It looks like 2 ohms. So we're gonna get 6 amps. Now this 6 amps will split up, some on top, some on bottom, but total current is gonna be 6 amps in the series part going through. To find the total power, we're gonna do 12 volts times 6 amps. This can give us total power of 72 watts coming off this. So another one here. Let's not find voltage drop. Total resistance. All right, so here we have a parallel part and we have a series part. All right, to find the total resistance, everybody here has to go through the 3 ohm resistor. This is in series, but we have 2 2 ohm resistors in parallel. So we're going to turn these 2 2 ohm resistors into an equivalent resistance. What would it look like in series? To that, we would take 1 divided by 2 plus 1 divided by 2 equals 1 divided by x. And so 1/2 plus 1/2 is 1. 1 equals 1 over x. X equals 1 ohm. This right here, this parallel part here, looks like a 1 ohm resistor. So our total resistance then, we add to the 3 ohm, which everyone goes through 2. This looks like it's 4 ohms. So the total resistance of this entire day is 4 ohms. Even though your options are you have to do a 3 and one of these 2, because we gave you a choice, you feel better about it. So you feel less resistance. All right. Total current then, 8 volts, divided by the total resistance, 4 ohms. This is going to be 2 amps. Our power is going to be the voltage times the current, 8 volts times 2 amps. This equals 16 watts coming off the line. Now some quick math for you guys out there. If you have resistors that are the exact same, so we have 2 and 2 in parallel. If you ever have 2 resistors that are the exact same, then you can just take the number divided by 2 and that'll be the resistance. So if you have 2 2 ohm resistors in parallel, it's 1. If you have 2 4 ohm resistors in parallel, it's 2. If there's 2 8 ohm resistors in parallel, then it's 4. That's what it looks like over here. And if you have more than 2, you can just divide by the number there. So for example, if you had 3 12 ohm resistors in parallel, rather than doing 1 over 12 plus 1 over 12 plus 1 over 12 equals 1 over x, if they're all the same, you can just take that resistor divided by 3. 12 divided by 3, this is 4. If we throw another resistor on there, now we have 4 12s in parallel. 12 divided by 4 is 3. So in parallel, if every single resistor is the exact same resistor, you just divide by the number passed, and that'll get you the equivalent resistance, what it looks like. If they're not the same, then you got to do the 1 over r plus 1 over r. In this class here, if it's more than 2, I'm going to give you the same ones, I think. All right. All right. God's peace. Have a great day.